Hello, and welcome to this section on our first project for machine learning in Sagemaker. In this section, we will go through all the necessary steps required to run the basic machine learning project on Sagemaker environment. This will help you in understanding the overall working of interconnected services for running a project in Sagemaker. The project we will focus on is the Titanic survival prediction. Before we move on to the project, it is important to understand the problem statement that we are to solve. So in this project, we will train a machine learning model to predict the survival of passengers. So if we have a look at the dataset, here it is. We have the columns labeled as passenger ID. Then we have the survival values where 1 means that the passenger survived and 0 means they couldn't survive. Then we have the passenger names, their gender, age, and followed by siblings or spouse, if there were any who were traveling with the passengers. Then we have the column which gives the information about the number of parents or children traveling with the passengers. Then the ticket number, the ticket fares, and then finally the cabin in which the passengers were traveling and their embarked field, which gives information about where the passengers boarded from, or you can say which station they were boarded from. So in our project, we will transform this dataset into some meaningful information for training our model. You can have a quick look at the age column and see that we have some missing values. We will look at how you can cater them so that the trained model is not affected. Likewise, many other features transformation as well. And finally, the model will then be able to predict the passenger survival for the provided test dataset. In our next lab session, we will start from the basic step of importing the dataset to the Jupyter Notebook, as we have already uploaded our data in the S3 bucket itself. So see you then. Hello and welcome to this lab session. In this session, we will look at how you can import the dataset from S3 to the Sagemaker Notebook instance for this project. The dataset for the Titanic project can be downloaded easily from the Kaggle. Just follow the link provided here and this will redirect you to the page for the dataset. Just scroll below and under the summary you will find the link which says download all. Click on this link and you will get a zip file containing the CSV files. And then following the steps discussed in the previous section, you can then upload the dataset in your S3 bucket. We have already done this, so I will start from importing the dataset file from S3 to Notebook. So coming back to the Notebook, I will import some necessary libraries that will be required to process the dataset that we will be importing. So for that, I have first imported here the pandas library as PD. It is a popular Python-based data analysis toolkit. It presents a diverse range of utilities ranging from parsing multiple file formats to converting an entire data table into a NumPy matrix array. Next, I will import the matplotlib library with pyplot. Pyplot is a collection of functions in the popular visualization package matplotlib. Its functions manipulate elements of a figure such as creating a figure, creating a plotting area, plotting lines, adding plot labels, etc. Alright, so let's now import our dataset. So this is a screenshot of the files that we have already uploaded in our S3 bucket. And here you can see that the file is uploaded at the location with bucket name Titanic-SageMaker.project, and in there we have a folder with name dataset. Let's import and read our CSV file. So for this, in the first line, we have provided the variable name bucket with a path for our bucket and the folder. So you can see this over here. Then in the second line, the data key is the actual file that we want to load. The complete path is stored in data_location variable in line number 3. So it becomes S3 followed by bucket name, the folder name, and then the key. Here the first curly bracket is referenced with the first value in the dot format arguments, which is the bucket variable, and the second curly bracket is a reference for the second argument value, which is the data underscore key variable. Finally, in line number 5, we will call the pd.read function from pandas library, which will load the file from the data underscore location variable path and store it as a data frame in the variable df. Let's run it. Okay, so the set is executed, and now let's see what we have in the variable df. Let's run this line. Okay, so you can see that we have the dataset for the Titanic passengers, and it has all the columns which we saw previously. And it shows that we have a total of 12 columns and 891 rows. Now, df is the variable which we will use throughout to perform the feature engineering and the data analysis. So this is how you load the dataset to the notebook from S3. And in our next lab session, we will perform the exploratory data analysis on our dataset. Hello, and welcome to this lab session. In this lesson, we will look at how you can perform the exploratory data analysis on the Titanic dataset. Exploratory data analysis is used by data scientists to analyze and investigate datasets and summarize their main characteristics, often employing data visualization methods. It can also help determine if the statistical techniques you are considering for data analysis are appropriate. This is one of the most important steps in machine learning model training, and this helps you for the next stage, which is the data cleaning, or you may say the feature engineering process. Let's get started with the EDA for this dataset. First, let's see the information for the data frame we have. So for that, we use the function .info. Let's run this line. This gives you the general information about the data frame for the Titanic dataset. Here we have all our columns listed and their value count. As we have already seen that the dataset contains 891 rows. Here, this means that now for all the columns, you must have 891 data points, which can be seen for all our columns. Like for passenger ID, we have 891 non-null values, then for the survived column, and so on. But if you notice for the age column, you will find that we have 714 non-values. And this gives us the information about the age column that we have 177 missing values. And also for the cabin column, we have 687 missing values, and then for the embarked, we have 2 missing values. We will see later on how you can cater these missing values. Now let's move on to the statistical description for our dataset. So here we have used the .describe function. This gives you the statistical analysis on your dataset. So here in the first row, you have the total count for data points in each numeric column. Then we have the mean values, their standard deviation, the minimum values followed by the percentile, and the maximum values. Looking at the table, we can say that the maximum fare the Titanic passenger paid was 512. Similarly, if you see at the sibling spouse row, we can say that the maximum number of sibling or spouse with one of the passengers was 8. Let's have a look at the shape of the data, and let's run this command df.shape, and it says that we have 891 rows and 12 columns. If you are interested in looking at the bottom end of the data, you can use the function .tail followed by the data frame variable. And if we run this line, we get the bottom end rows of our dataset, and similarly you can also use the .head function to look at the top rows of the dataset. Both these functions will return the 5 rows. Let's perform some data analysis. So here I have already mentioned the details that each of the column labels in our dataset describes. So first we will look at the data type for each of the columns. So for that I have used the command .types. Let's run it. And here we have the data type for each column. Alright, so the first analysis I'm going to apply is the number of survived passenger. For that I will make use of the .value count function in line number 1 here. Here I'm saying the notebook to fetch for me the value counts for the survived column from the data frame. Let's run it. And here it shows that the total value count of 1 is 342 and that for 0 is 549, as 1 represents the survived passenger count and 0 represents the dead passenger count. We can say that a total of 342 passengers were able to survive in the Titanic ship sink. Next, let's have a look at the gender count. So this will show us how many passengers were male and how many of them were females. So we get the answer that 577 were male and 314 were females. Well, at times, the EDA process just with the numerical values looks boring at times. So you can also make use of the visuals to make this process interesting. So for that, I have over here this line of code which will return us the bar chart for the gender value count which we just saw. Let's run it. And here we can see the counts for male and female. By looking at the chart, we can say that the males were more than the female boarded in the Titanic ship. Let's also quickly have a look at the histograms for the fares. Let's run it. And here you can see that the passengers who paid a fare of $0 to $50 were more than 700. Also, passengers who paid fares in the range of 50 to 100 were around 100. And then if you see at the $500 fares, there were few passengers paying this much amount. I believe that was a business class ticket. Alright, so this is it for the EDA process for this dataset. Definitely you can perform some more analysis as well, and we will perform most of them in the next lab session. But the goal for this course is to train our models on the Sagemaker environment. So for that I will keep this lesson short and we will focus more on using the environment to train and deploy your models on Sagemaker. In our next lab session, we will perform the feature engineering, or you may say the data cleaning, and then we will move on to training our model. Hello and welcome to this lab session. In this lesson, we will look at how to perform data cleaning on your dataset, and the dataset we have is the Titanic dataset. The main aim of data cleaning is to identify and remove errors and duplicate data in order to create a reliable dataset. This not only improves the quality of the training data for analytics, but also enables accurate decision making for the trained model. So for the Titanic dataset we will be performing these data cleaning tasks. The first will be to extract the titles from the names. As you have seen that the title is merged with the names of the passengers. So this will be helpful to estimate the age of the passengers for those that are missing. Then we will change the gender labels, that is male and female, to the numeric values, because you know that machine learning is all about numeric computations and you cannot have string values in the dataset. Even if you have them, you need to convert them into a numeric equivalent data. Next, we will fill in the missing information, that is the age in our case. And finally, we will categorize the uncategorized dataset values that we have. Let's get started. So before we begin with the data cleaning, let's have some pre-processing data analysis that will help us in cleaning the data. So first I will import some Python visualization libraries. So our libraries are imported. And in the next cell, I have defined a function here that will plot the bar chart for the selected features in reference to the survived and the dead passengers. So that is actually what we'll be predicting and our model will be trained for. Also in the first line, I have made a copy of my original data frame, just in case my original data frame does not get affected by any wrong manipulations. Alright, so first I will plot the bar chart for the gender features. Let's run it. So you can see that it shows the surviving and dead passengers for both male and female. By looking at the graph, we can say that the females were the most likely to survive and most of dead passengers were males. Next, let's have a look at the passengers class based bar chart for survived and dead passengers. Let's run this cell. Okay, so the graph shows that the passengers in the third class, that is in the green color, were dead more likely than other classes. And the passengers in the first class survive more than any other classes. Next, let's have a look at the survival of siblings and spouses. Let's run this cell. So here we come to know that a passenger with no sibling or spouse was more likely dead as compared to the others. Another quick analysis can be done on the parent-children survival. Let's run this cell. And here we can see that the passengers with no parent or siblings were less likely to survive as compared to others. One more analysis can be performed on the title-based survival, which will give us the information that which title-named passenger was able to survive and which were not. But there is an issue. If you remember, the titles are merged with the names of the passengers. So to plot the title-based survival, we need to do two things. First, we have to separate the title from the name, and then we will have to convert the titles into some numeric values to categorize them. Let's do it. So over here, I have copied the data frame in a new variable named df_new as array type. And then I'm extracting the titles from the name column and storing it in the new created column labeled as title. Let's run this cell. Okay, now let's have a look at our new data. So here you can see that a new label is created with the name as title, and the titles are available to us. Let me quickly show you the title count for the complete data set. And here it is. It can be seen that we have 517 titles for Mr., 182 for Miss, and so on. The next step is to convert all of the titles to a numeric value to categorize them. As this is also one of our data cleaning steps, let's start processing it. As we can see that the maximum title count we have is for Mr., Miss, and Mrs., so we will categorize these separately. Rest all other titles, I will merge them in a category named as others. So the definition for my titles will be 0 for Mr., 1 for Miss, and 2 for Mrs., and 3 for others. So in this code cell, I have declared the title mapping as you can see. And inside the for loop, we will map the numeric titles with the original ones in the title column. Let's run it. Alright, so the code is executed. Let's look at the data frame head. So here we have the titles replaced with the numeric mappings as we defined earlier. Let's now plot the bar chart for the title-based survival. So here you can see that we have the plot which shows that the passengers with the title as Miss were more likely to survive than others. And this is the same information that we got from the gender-based survival plot as well. So this is how you perform some pre-processing and cleaning of data. We have more cleaning left to be done before we start the model training. So in our next lab session, we will look at some more data cleaning on our dataset. Hello and welcome to this lab session, which is the continuation of the previous lab on data cleaning. The next thing we will be doing is changing the gender names, that is male and female, to the numeric values 1 and 0 respectively. For this I have used the replace function, which will replace the data points in the sex column. For male, it will replace all values with 1, and for female, it will replace all values with 0. Let's execute this cell and have a look at the data frame head. And here you go. So we have the gender values converted to numeric equivalent values. Alright, so the next task in data cleaning is to fill in the missing information. Let's get started first finding the missing information for us. So for this, I will first look at the shape of the data. So I have 891 rows and 13 columns. Next, we look into the information. The shape gives us a total of 891 rows, but we see in the above info that there are 714 non-null counts for age, 204 non-null values for cabin, and 889 non-null values for embarked. There should be a total value count of 891 as that of others. This shows some data is missing. Let's have a clear picture of it. So for this, we will look at the null values. Now let's run this cell. So you can see that we have 177 missing values for age column, 687 missing values for cabin, and 2 for embarked column. Next, we must know whether the data for each feature which is not available is important for us or not. But that depends on what type. So from a quick view, we can say that the age feature is of more importance for us rather than the cabin and embarked feature, because the age value is directly linked to the passenger's identity. Let me discuss with you the approach that we will follow to fill in the missing ages. You can follow any approach, but in my case, I will fill in the missing values with respect to the title numeric values. So to fill in the ages of males, we will take the mean of the male titles for each passenger class. Similarly, the same goes for the females. So here I have a variable with name missing_ages, and I will copy the data points for which we have the ages missing. In short, when we run this cell, we will have the dataset values for which we have missing age values. Let's run it and see the missing ages variable dataset. So you can see that all the values have age value as null. And for this variable data frame, we have 177 rows and 13 columns. Okay, so now with my defined approach, I am now calculating the mean ages with respect to the titles in the original data frame and the passenger class. Let's run the cell and then have a look at the mean_ages values. So here you can see that for each gender category and under that for each passenger class, we have their respective mean ages. Let's now fill in the missing age values. So for that, I have defined a function here with the name fill null ages values. This function checks for if the age is null and replaces it with the mean value from the mean ages variable. Let's apply this function to the age column of the data frame. Okay, so the cell is executed. Now when I check the null values, so it must show no missing values in the age column. We now have no missing values for the age column. Alright, so the next task we are to do is to categorize the uncategorized data. So we have the age values and we will bin it according to the age range in a way that we have categories for child, then young passengers, the adults, the mid-age and the seniors. Let's run it. So this is the data frame we have as of now. So here we have the categorization process for the passengers according to their ages. For passengers having age less than 16 is assigned category 0. That is the child. Then we have an age range from 16 to 26. That will be category 1. Those are the young ones and so on. Let's run this cell. Here, let's have a look at the updated data frame. So now you can see that the age is binned into categories. Reason being that we cannot handle all the age numbers in the dataset for model training. Now, all the ages are binned into 5 categories as per the vector map defined. Let's have a look at the bar chart for the binned age. And here you can see that the passengers in the age category 1 and 2 were most likely dead as compared to others. Alright, so next and finally, we'll drop all the unwanted columns from our dataset. So we will drop the passenger ID, the name, ticket number, cabin, and embarked columns as they are of not much importance to train the model. Let's execute it. And finally, let's have a look at the processed dataset that we have now. So here is how our dataset data frame looks like, and now we have 891 rows and 8 columns. Out of these 8 columns, 1 column is for the output and 7 remaining columns are the features for the dataset on which the machine learning model will be trained. So I hope you have got an idea on how to perform the EDA and the data cleaning on the datasets. So in our next lab session, we will look at splitting the dataset into the training and testing dataset. Hello and welcome to this lab session. In this lesson, we will look at how to split the dataset we have into the training and testing. In that case, the trained data will be used to train the model, whereas the test data will be used to test the model. Separating data into training and testing sets is an important part of evaluating data mining models. By using similar data for training and testing, you can minimize the effects of data discrepancies and better understand the characteristics of the model. So over here, we will define the input and output for the dataset. Our inputs are the features, so I'm storing them in variable X, except the survived column, as it is the output in our case and I have saved it in variable Y. Now here I will display the variable X. So you can see we have all the features in here. Then let's also have a look at the output. So we only have the survival answer. Now let's quickly have a look at the shape of X and Y. So now we know that X is our dependent variable as it contains all features to train the model, and the independent variable is Y. So using here the dot values command to convert the values to list, and in the next cell we are converting the data type of X and Y variable values to float 32 as it is required for Sagemaker processing, and that is what the Sagemaker linear learner algorithm expects. Next, in using the scikit-learn library, I have imported the train test split module that will help us split the dataset into the training and test part for us. So here we have splitted our dataset with a test dataset size of 30% randomly. Now let's run it and then see the shape of our training and test datasets. It can be seen that we have 623 values for the trained dataset and 268 for the test dataset, which is 30% of the complete dataset. Now that we have split the dataset, we will move on to the training the model part in our next lab session. Hello and welcome to this lab session. In this lesson, we will learn how to train machine learning project in Sagemaker. First, I will be importing the necessary Sagemaker libraries required whenever you are to train your model with Sagemaker Notebook environment. So the first library we have here is the Boto3. Boto3 is the name for Python SDK for AWS. It allows you to directly create, update, and delete AWS resources from your Python scripts. Next, I am importing the Sagemaker library. And From there, I'm importing the module getExecutionRole. As a managed service, SageMaker performs operations on your behalf on the AWS hardware that is managed by SageMaker. SageMaker can perform on only operations that the user permits. A SageMaker user can grant these permissions with an IAM role referred to as an execution role. To create and use a locally available execution role, you can use the following procedures, where we have in line number 6 and 7. So we get the current session of the SageMaker and its role. This is the IAM role that you created for your notebook instance. Now let's have a look at a brief introduction on SageMaker algorithm, linear learner. So linear learner is a supervised learning algorithm where you have input variables and an output variable y. And you use an algorithm to learn the mapping functions from the input to the output. The goal is to approximate the mapping functions so well that when you have new input data, that is x, that you can predict the output variables y for that data. This algorithm can be used for both regression and classification. In regression, output contains numeric continuous values, and in classification, we have two cases, binary classification and multi-class classification. So in binary class classification, output label will be either 0 or 1, whereas in multi-class classification, output label will be from 0 to number of classes minus 1. Next, we have imported the linear learner model training module from the SageMaker library. I have also created a folder in my bucket with the name smout. This will contain the trained model once when it is trained. Let's now instantiate the linear learner. Our role will be the same role that we have fetched previously using the getExecutionRole function. We will be using a single instance of ml.m4.xlarge type. Then we define the predictor type for this linear learner algorithm, that is binary classification. The output path is the same we define here in line number 7. Then we have the session, which is the current one we are using for which we previously fetched the IAM role. Then I will be using 300 epochs to train my model. The number of model here is the number of models to train in parallel. If not set, the number of parallel models to train will be decided by the algorithm itself. And here this is 32 for our case. Then we have used the loss parameter as logistic. To interpret this score in classification problems, you have to consider the loss function. And for binary classification, the loss hyperparameter value is logistic. And softmax for the multi-classification is used. Now over here, these three lines, 19, 20, and 21, are used over here to reduce the billing seconds for your AWS SageMaker usage. If you don't use them in that case, your spot instances won't be used and all the training will be done using a single instance that will be built higher. The spot instance uses the available free instances that are not being used and uses them in parallel to reduce the overall build time for your instance. Now let's run this cell. So by now we have defined all parameters and essential settings that are required to train the model using the SageMaker environment. Now we will feed the data in through the record set. The first one we have is the trained data, where we have provided our training data inputs and outputs. This basically produces a record set object for the model training process. In the same way, we have the validation set. For the validation, here we have provided the channel name as validation. This is because we want our data X set and Y set to be assigned to it. And this will be used to test our trained model. We can now train the linear learner estimator by supplying the training and validation record set objects. Over here, the linear.fit command will start training of the model. Once the training job is started, you can see it is in your Sagemaker dashboard as well. Let's run this. Let me take you to the dashboard. And here on the left sidebar under the training job, you will find the training jobs option. And you can see here that it is in progress. Once it is completed, the status will be changed to completed. This will take some time to completely train the model. We will continue deploying the model from our next session, and I will show you what the output looks like after the model is trained. Hello and welcome to this lab session. Now that our model is trained, and if you go to the dashboard, under the training tab, just click on the training jobs and you will find the training job that we just completed. And here it is. Now it's time to deploy the model and get some results. To host a model through Amazon EC2 using Amazon Sagemaker, we deploy the model that was trained in the previous lab session by calling the deploy method of the linear learner estimator. When we call the deploy method, we must specify the number and type of EC2 machine learning instances that we want to use for hosting an endpoint. I will deploy the model and we can reference it using the variable name linear_bin class. So here in the arguments, I am telling that I will use a single instance and the instance type is MLT2 medium. Let's run it. This will take some time to deploy the model. Meanwhile, let me explain to you how it works. When you develop a model in Amazon SageMaker, you can provide separate Docker images for the training code and the inference code, or you can combine them into a single Docker image. Using this powerful container environment, developers can deploy any kind of code in the Amazon SageMaker ecosystem. You can also create a logical division of labor by creating a deployment team, such as DevOps, security, and infrastructure team, who maintains the container, and also a data scientist team who can focus on producing models that are later added to the container. Over here in the diagram, if you see, we initially stored our training dataset in S3 bucket, which is placed over here. Then we did all the pre-processing, which is done in the ML work directory, and started all the model training part. This all is done on ML compute instance, which all depends on the type of machine learning project you are working on. Once the training job is executed, the model artifact is stored on the provided output location in the S3 bucket. Now the next part that comes in is to deploy the model that we are doing right now. Once the model is deployed, the model is available to perform the predictions and the endpoints are also created. Now it is the endpoint using which the data can be input and the predicted results can be output. We can pass data in a variety of formats to our inference endpoints. In this example, we will demonstrate passing CSV formatted data. Other available formats are JSON formatted and record IO protobuf. We make use of the SageMaker Python SDK utilities, that is CSV serializer and JSON deserializer when configuring the inference endpoint. So here in the next cell, code here, you will find that we have imported CSV serializer and the JSON deserializer. Then we have specified here that the content type we have is the CSV or text type, Serializer is used for the input to the model endpoint. This means we are using the CSV serializer as our data is in CSV format. And the output which is deserialized will be received to us in JSON format. Now that our model is deployed, and if you go to the dashboard, under the Inference tab, just click on Models, and you will find the model that we just deployed here. You can also see that endpoints have been generated, and it will show us up in the endpoint section. Here it is, that is in service. Now let's move to the dashboard. So in our next lab session, we will use this endpoint to start our predictions. Hello and welcome to this lab session. In this session, we will look at how to start prediction using the model we created in our previous session. Let's pass the test dataset in CSV format to the inference endpoint so we can predict the Titanic passenger survival. Note that the serializer and the deserializer will automatically take care of the data type conversion from NumPy and the arrays. The result will be saved in the result variable. Let's run it. So here you can see for all the test dataset we get the result score, and this is all in the JSON format. Here the model returns a score and also a predicted label. The predicted label is the class predicted by the model, and the score measures the strength of that prediction. I'm saving all these results in the prediction variable in the array format. So the np.array function here extracts the scores from the JSON output from the result variable and stores it in the prediction variable. Let's run it and see the output. And here all the output is converted to array format. Let's now compare the actual and the predicted output that our model has predicted. Here you can see the output, and one thing is to notice, we get the output in the floating point. What you can do is to convert the output to integer format using a threshold, that if the value is equal to or greater than 0.5, it is a 1, else it be a 0. In this way, you can observe that the predicted and the actual output then look similar. We can also visualize this with the help of the graph. Here we have the blue color bars representing the actual values, and the brown ones the predicted one. So our model seems to predict accurate results over here. One more important thing is to ensure that you always delete the endpoint once you are done predicting with your trained model. This can be done using the code snippet in the last line, or you can go to the dashboard and here under the Inference tab, select the endpoints. This was our endpoint. Let's select it, and here you can select the delete option. This will delete the endpoint, and if you don't do this, you will incur charges till the time the endpoint is available in your Sagemaker account. So I will delete it from my notebook instance. So over here, I will run this cell, and this deletes the endpoint. This can be seen over here as well. Now we don't have any endpoints left. So this is how you train a model in Sagemaker and predict your results. This was a basic project on machine learning.